All right, here's lesson 3, multiplying and dividing rational expressions. So one thing to kind of remember here when you're multiplying a fraction, you're going to multiply your numerators and multiply your denominators. So here you'd get 3/8, okay? But there is something to kind of make note of. If I have something like, say, 1/2 multiplied by 4/3. Let's take a look at this 4 here. This would be equivalent to, 4 is the same as 2 times 2/3. Okay, and if we put that all together, the numerators, you can see that part of the numerator and part of the denominator will simplify to 1. So let's kind of keep that idea in mind when we do this here. So multiply the numerators together, multiply the denominators together, and then reduce. State the restrictions on the variables. So here, we're going to multiply the numerators, and we're going to multiply the denominators. So 12 times 3 is going to be 36. X and x gives us x squared, y, z squared. Okay, divided by 4y, z. And now we have to reduce. And this is maybe an important time to maybe review some exponent rules. If I have x squared over x1, what's going to happen here is we're going to subtract one of them and we're going to get x squared. And if you have something like y5 over y cubed, this is the same as subtracting our exponents. Okay? So let's go through this and simplify. So 36 divided by 4 is going to give us 9. And then we've got x squared, but there's no x in the denominator. So x squared is just going to still remain, x squared. I'm trying to write with a highlighter. All right, then we've got a y in the numerator and a y in the denominator. So both of those are actually going to simplify to 1. And then we've got z squared in the numerator and z in the denominator. So what happens here is this will cross out, but we're going to subtract 1 from that exponent. And we're going to be left with z. Z to the exponent 1, but we'll leave it like that. Now we do have to talk about some non-permissible values, and this happens before we simplify. Because obviously we can see that there are going to be some non-permissible values, but after we simplify, you can see that we have no denominator. So we need to make sure we're going to do our non-permissible values or restrictions on the variables before we simplify it. So y cannot equal 0 and z cannot equal 0. All right. Here we're going to multiply 5 and 35. We're going to get 175. And then we've got the a squared. This isn't going to be multiplied by any a's over here. And then we've got b squared and b1, so b cubed is what we get. And c4, there's nothing else to multiply by, so it just stays c4. Now, over top of 14 multiplied by 40 gives us 560. A cubed, b squared, c squared, d. All right, let's take an opportunity to talk about our restrictions on our variables. So a cannot equal 0, b cannot equal 0, c cannot equal 0, and d cannot equal 0. All right, now let's reduce this. 175 and 560. This will reduce to 5/16. And I will show you a calculator trick in class to speed up your life. We have b cubed in the numerator. We have a squared in the numerator and a cubed. So we're going to be left with an a in the denominator. We have b cubed in the numerator, b squared in the denominator. So we're going to be left with b in the numerator. c4 and c2 will leave us with c squared in the numerator. And we have d in the denominator. So this is what it reduces to. All right, simplify. State the restrictions on the variable. Now actually, I'm just going to come back to this question here. And let's rewrite it. over top of 14 b squared cd, and then we're going to multiply this by 35 b over 40. Okay, so when you multiply the numerators, instead of multiplying 5 and 35 to get 175, I'm just going to leave it as 5 multiplied by 35. Now 35 can be written as a product of primes, 7 times 5. So what you can think about is 35 is the same as 7 times 5, okay? And then we have a squared b cubed c4. That won't change. All right, 14, that can be written as a product of primes, 2 times 7. And 40, if you were to prime factor 40, you'd get something like this. So 2 cubed and 5. All right, so if I would just want to write it all the way out, 2 cubed and 5, and then we've got c squared, or a cubed, cb squared, c squared d. All right, so instead of combining these numbers to create one number, like 560 or 175, I'm leaving it almost in prime factor form just to show you something here. And we could simplify this 5 and this 5. We could simplify this 7 and this 7, and I think that's it. So you can see where the 5 comes from, and then 2 times 2 times 2 times 2 gives us the 16. Okay, so you can kind of write it like that and then simplify that way. All right, so let's simplify these. If you notice, we've got an x plus 1 in the numerator and an x plus 1 in the denominator. So something in the numerator and the denominator, that's going to simplify to 1. X plus 3 in the numerator, x plus 3 in the denominator, that is going to simplify to 1. And that's everything. Nothing else will simplify. So we can simply write this as 2 in the numerator and then x and x minus 2 in the denominator. However, we do need to do our restrictions at this stage, not after we've simplified. So x cannot equal 2, x cannot equal negative 3, x cannot equal 0, and x cannot equal negative 1. Now you don't have to write x equals all the time. You can just write it as x cannot equal 2, negative 3, 0, negative 1. Okay, taking a look at this next one here. First of all, let's factor the numerator. So 4x plus 4, and then 7, 2x minus 1, multiplied by 2x minus 1 over x plus 4, and I'm just going to expand this x plus 4 squared. All right, x plus 4 will simplify, 2x minus 1 will simplify, and let's write down what we have left. Anything else? Nope. So we've got 4 over 7, and we have an x plus 4 in the denominator. Now restrictions on our variables, x cannot equal 1/2, negative 4, and that's it, because that one gets repeated. Okay, factoring the numerator to start, we get 2m squared and m minus 2, and we get 3m, m minus 3, and we're going to multiply this by m minus 3, m plus 2, and m plus 2, m minus 2. All right, we could do our non-permissible values at this stage, so m cannot equal 0, 3, negative 2, or positive 2. Now let's do some simplifying. So m minus 2, m minus 2, m plus 2, m plus 2, m minus 3, m minus 3. And an m and that will simplify. So we are going to be left with 2m over 3. All right, we're going to do some serious factoring here. The first numerator is going to be a plus 5 and a plus 3. So when you're watching these videos, I would encourage you to pause, try and factor, and then click play and see if you end up with what I end up with. Okay, and our denominator, we're going to get 3. And then I'll do this factoring in 2 stages. And then this numerator is going to be negative a, and 4a squared minus 1. That's a tricky one, okay? Maybe think about, how did I go from there to there? Over top of 2a minus 1, a plus 5. Okay, and then I'm going to factor this one a little bit farther, and this one a little bit farther. Oops, equals a plus 5, a plus 3, and then this gets 2a plus 1, a plus 3, and then we're multiplying by negative a, 2a plus 1, 2a minus 1, over top of 2a minus 1, a plus 5. Okay, we've done the hard part. Now we need to do some simplifying. So a plus 5, a plus 5, a plus 3, a plus 3, 2a plus 1, 2a plus 1, and 2a minus 1, 2a minus 1. All right, so maybe let's just highlight what we actually have left, because it gets a little greasy. So that's what we have left. So we're going to be negative a in the numerator and 3 in the denominator. One thing I didn't do is our non-permissible values, and that needs to be at this stage is probably the easiest, fully factored. So a cannot equal negative 1/2, negative 3, positive 1/2, and negative 5. All right, dividing rational expressions. If you can multiply rational expressions, you can divide, because there is one extra step. So the first step is factor. The second step is list your non-permissible values. Third step is probably the key one here. Multiply by the reciprocal and list any new non-permissible values. And your last one is to simplify. So a couple of things, the reciprocal. So if I have a fraction like 1/2, actually let's do a different number, because then you can actually see. All right, like 3/5. The reciprocal is 5/3. Okay, so what happens here is the numerator and the denominator swap places. Okay. So here we go. Ooh, what happened? There we go. Let's first of all factor the numerator if we can. So 16a, nothing really here to factor. They're just kind of sitting there. So let's start by writing down some non-permissible values. So right now b cannot equal 0 in either case. Okay, if you put a 0 in there, you're going to get a denominator of 0, and it's not going to work out very nicely. Okay, check to see if there's anything in the numerators. No, nothing's going to simplify there. Nothing's going to simplify there. Okay, so right now we're kind of stuck. Nothing simplifies, nothing factors. However, when we multiply by our reciprocal, we suddenly end up with something in the numerator and something in the denominator that could simplify. We also get a in the denominator. So a in the denominator means we have a new non-permissible value. A cannot equal 0. Now let's go ahead and try and simplify some stuff here. I know that 32 is 2 times 16. Okay, so let's keep that in mind. So what's going to happen is we get, oops, if I get a pen color here, 16 multiplied by a multiplied by 15 multiplied by b. That's our numerator. Okay, and then we get 9 multiplied by b squared multiplied by 32 multiplied by a squared in our denominator. Okay, so 16 and 32, those are going to simplify. I am going to be left with 2 in the denominator. Okay, 32 is twice as big as 16. All right, a and the a squared part will simplify. B and the b squared part will simplify. And then 15 and 9 are both divisible by 3, so I can reduce them by 3. So this reduces to 5. Put that up front. And this reduces to 3. Now, if that's a little confusing, I'll do it another way in a second here. So we're left with 5 in the numerator. We're left with 6 in the denominator. We also have an a and we also have a b. Okay, 6a, there we go. And that's our simplified expression. All right, if that was a little bit confusing to you, just think about what 16 and 32 means. Okay, so 32 is the same as 2 times 16. So I'm simplifying the 16 part, but you still have the 2 part. So that's where that 2 came from. And then same with 15 and 9. They're both divisible by 3. So 15 divided by 3, or if I factor out a 3, I'm going to be left with 5. And same with 9. If I factor out a 3, I'm left with 3. Okie dokie. Here's another one. Can we simplify anything at the beginning? So let's expand everything here. Non-permissible values. So x cannot equal 0. And z cannot equal 0. We get the same x and z thing going on there too. So far we have x cannot equal 0. Whoops, not equal and not equal 0. So let us multiply by the reciprocal. So this is where the negative 21z4 comes up, and the 10x squared y squared goes down. All right, let's multiply our whole numerator and multiply our entire denominator. So pause the video, see what you get. I'm going to create one whole number on the numerator. So negative 5 times 2 times negative 21 is 210. X, y cubed, z5. And 7 times 15 times 10 is 1050. X4, y squared, z cubed. Okay. Now 210 and 1050 will reduce by 1 over 5, meaning that 210 is 1 times 210, and 1050 is the same as 5 times 210. So those two 10s will simplify, and you're left with 1 over 5. Okay. Then we can simplify the x and the x4. So this part here is this. So what happens here? Well, one of the x's simplify. You're still left with x cubed in the denominator. And then we've got y cubed and y squared. So y cubed means y times y times y, and y squared means y times y. So two of those will simplify. You're still left with a y in the numerator. And then lastly, I'm just going to erase some stuff here. The z5 and the z3, you can see that 3 of them will simplify, and you're still left with z squared in the numerator. Now, one thing to note, you do not have to leave a 1 here. Okay? Let's update our restrictions. We ended up with a y in the denominator, so we need to add y cannot equal 0. 2 more examples here. All right, so there are 2 more examples on this page. Simplify state restrictions on the variable. Okay, so we can't simplify anything right away, but if we multiply by our reciprocal, I'm guessing, because it's one of our examples, and it's in this unit, that something is going to simplify. Hopefully more than one thing. Okay, so non-permissible values. Right away, x cannot equal 2, negative 3, 0, or negative 3. That's the same. And we end up with another one, negative 1, that it cannot be. Okay, let's do some slashing and dashing. So the x plus 1, x plus 1, x plus 3, x plus 3. And I think that's it. So we're left with x in the numerator and then 2x minus 2 in the denominator. Okay, step 1, factor. Factor, factor, factor. So factoring out of 4 leaves us with x plus 3. Factoring out of 3 leaves us with x plus 4. And we're still divided by this. And then I'm going to write this expanded. Okay, non-permissible values. Again, you don't have to write NPV, but useful to note. So x cannot equal. We got -4, -4, -4. Okay. So at every stage here, it's always -4. We just write it down once. Let's multiply by our reciprocal. No, that is not our reciprocal. Okay. And we end up with 2 more non-permissible values, 0 and -3. Beautiful. Slash and dash in time, x plus 3, x plus 3, x plus 4, x plus 4. And that's it. So we are left with 4 and x plus 4 in the numerator, and then 3 times 3x, which is 9x in the denominator. Wonderful. Okay, getting a little bit more greasy, but a good chance to practice your skills. So, factor. Pause the video, see what you get. My iPad's dying, so let's see if we'll make it. Okay, factoring out of 4x gives us 3, oh my goodness, x minus 3. And then we get x minus 3, x plus 3, divided by, let's factor out a 7x squared, and we get x plus 1. And then this will factor to x plus 1. All right. And let's multiply by let's start our non-permissible value. So x cannot equal plus or minus 3 and -1 to start. And go ahead and multiply by our reciprocal. Did it again. Okay, and 7x squared, x plus 1. Slashed and dashed time. Oops, before we do that, did we get any new non-permissible values? Yes, we got 0. And that's it. Okay, x plus 1s, see you later, x plus 3, x plus 3, x minus 3, x minus 3, and we're going to simplify that exponent. So we're going to be left with 4 in our numerator, and looks like 7x in our denominator. Great. Okay. Looks complicated, but the factoring is probably going to be the hardest part here. One thing to note though, we're dividing by an entire expression that's contained within brackets. Okay, so we need to multiply by the entire reciprocal, not just part of it. You're not just going to reciprocate like this part and leave this part in the same form. We need to multiply by the entire reciprocal. Okay, factoring the 10m. And we're going to get 2m plus 3. Now this is a bit of a greasy difference of squares. If you rearrange and factor out a negative, okay, you get -4m squared minus 9, which is going to give us 2m plus 9, 2m minus 9. Okay, so that's a little tricky. So our denominator here is going to be -2m plus 3, 2m minus 3. okay? And let's do divided by, factor out an 11m. We're going to get m squared minus 1. Another greasy thing going on there. And then we get 2m minus 3 and m plus 1. And then we're multiplying, so I'm going to put this factor up here, 2m plus 3 over top of m minus 1. Okay. There's one more thing that we can factor, this m squared minus 1. That's a difference of squares. Okay, so let's leave the first part. We're going to multiply by the reciprocal. So this entire part here, I'm going to highlight in yellow. That's going to become your new numerator. Okay. So 2m minus 3, m plus 1, m minus 1. Okay, and then, carefully I can erase that highlighting. There we go. This entire, let's do a different color. This entire part is going to become your new denominator. Now I am going to do one thing here. When I write this down, I'm also going to expand this m squared minus 1. So we get 11m. This m squared minus 1 is m plus 1, m minus 1. Okay, and then we get 2m plus 3. Okie dokie, let's do some slashing and dashing. M squared, m minus 1, m plus 1, those go. 2m plus 3, 2m minus 3, the m and the m, and I think that's it. Okay, so we have 10 in our numerator. We have this negative sign, so I'm going to stick it out front. And then we've got 11 and 2m plus 3. Now one thing that I haven't done yet is our x cannot equal. And we're going to get negative 3 over 2, 3 over 2, negative 1, 1, and 0. And you could clean that up. You could say x cannot equal plus or minus 3 over 2, plus or minus 1, or 0. And we made it without the